This DVD explains the basic structures of marine auxiliary machinery with which a number of problems have been reported, and calls users' attention to operational precautions to be taken to prevent any trouble. In this sequence, we will introduce typical marine use pumps, such as horizontal volute, vertical volute, gear, 1 screw, 3 rotor screw, steam turbine-driven cargo, and LNG pumps. Horizontal volute pumps are relatively small. They are mainly used as freshwater and seawater service pumps. Relatively larger vertical volute pumps are used as main seawater pumps, cooling freshwater pumps, general service pumps, and ballast pumps. Since both types work basically in the same way, we will focus our explanation on vertical volute pumps, many of which are large. Rotation of the impeller creates a vacuum at the center of the impeller, allowing the liquid to be drawn in through the pump inlet. Given pressure and velocity energy by centrifugal force, the liquid is pushed out through the outlet. Such repetition of suction and expulsion allows the liquid to be pumped. Shown here are the main components of the volute pump: the shaft, mechanical seal, impeller, and mouth ring. Some vertical shaft pumps have a bottom sleeve. Let's look at these components one by one in their assembly process. This is a large bilge fire general service pump, a vertical 2-stage single suction type pump. The shaft with an impeller is fitted in. The mouth ring is attached. The coupling is connected. With pumps that have no line bearing at the bottom, alignment is fixed by motor coupling connection. The bottom sleeve is attached. The mechanical seal is already fixed on the shaft. The packing is applied. The pump cover is installed. The shaft begins to rotate smoothly. Here you can see the mechanical seal parts. They are the floating seat, O-ring, seal ring, spring, and stopper ring. The mechanical seal keeps air tightness by a combination of sealing in the shaft direction by the shaft-fixed O-ring and sealing in the radial direction by the sliding of the seal ring and floating seat. Key points for maintaining mechanical seal functions are that the O-ring does not deteriorate. The spring, which presses the sliding surface, functions well. The floating seat sliding surface has good durability. Flushing liquid used for cooling and cleaning the seal part keeps flowing. The following volute pump cases of trouble have been reported: damage to the bearing, damage to the mechanical seal, damage to the impeller and mouth ring due to cavitation, wear of the casing, and uneven wear of the bottom sleeve if the pump is vertical with a bottom sleeve. The following precautions must be taken in operating volute pumps. Consider replacement of ball bearings depending on duration of operation. Beware of negative pressure operation to prevent cavitation. During operation, beware of leakage from the gland. When using a mechanical seal, Beware of damage to the seal and confirm that the flushing liquid is flowing and the mechanical seal part is clean. Keep pressures always in mind and make a maintenance plan as necessary if a comparison of characteristic curves indicates a decline in pump performance. And with regard to a vertical pump, pay attention to vibrations that may affect shaft alignment. Gear pumps are mainly used as fuel oil and lubricating oil pumps. Rotation of the main drive shaft moves a space created between the drive and driven gears, thereby allowing a highly viscous liquid to be carried from the pump inlet to the outlet. Shown here are the main parts of the gear pump. They are the drive shaft, drive gear, driven gear, bearing, mechanical seal, oil seal, and relief valve. An oiler is attached to gear pumps and 3 rotor screw pumps. With the oiler, an oil chamber is provided on the atmosphere side of the mechanical seal, into which lubricating oil is sealed to cut the atmosphere off the sliding surface. This prevents fuel oil leaking out of the mechanical seal from solidifying. Replace lubricating oil if it has discolored and the oil level has risen beyond a specified level. The following cases of trouble with gear pumps have been reported. Damage to the bearing. Leakage due to damage to the mechanical seal. Leakage due to damage to the oil seal. And damage to the gears. The following precautions must be taken to operate gear pumps and conduct maintenance. Open inlet and outlet valves before starting the pump. Draw out air before starting the pump. Pay attention to any vibrations and abnormal sounds. Be mindful of bearing temperatures. Prevent contamination by foreign matter. Beware of leakage from sealing. Understand pump performance capabilities. Carefully conduct inspection and adjustment of the shaft alignment. Do not conduct dry operation. And if an oiler is provided, pay attention to any rise in the oil level and replace lubricating oil as necessary according to changes in its color. There are 2 types of screw pump, 1 screw and 3 rotor screw. The structure of the 1 screw pump is like this. Components are the oil seal, bearing, shaft, universal joint, stator, and rotor. The 1 screw pump is a kind of displacement screw pump and consists of a stator and rotor. If the rotor of a single-threaded male screw is turned inside a double-threaded female screw stator, the rotor turns inside the stator. The stator is made of a flexible material, and the rotor continuously moves from one space to another as produced between the rotor and stator. This is how pump action occurs, and its continuous movement transfers bilge containing foreign matter as well as viscous liquids. The 3-rotor screw pump consists of 1 power rotor housed in a casing and 2 idler rotors that are meshed with the power rotor. Main parts are the bearing, oil seal, mechanical seal, stator, power rotor, idler rotor, and casing. When the power rotor is turned clockwise, as seen from the drive side, the idler rotors turn in the opposite direction. This creates a sealed space per screw lead. It moves toward the discharge side along the screw shaft. Typical reported cases of trouble with screw pumps have concerned overheating of and damage to bearings. Be mindful of the following points: the rise in bearing temperatures, preventing air from entering, keeping pumping capacity and pressure within prescribed levels, clogging of the suction tube and strainer, maintenance of the oiler and mechanical seals flushing function in the case of 3-rotor screw pumps, and avoidance of dry operation. Steam turbine-driven cargo oil pumps are used on crude oil tankers. With its steam turbine side placed in the engine room, the cargo oil pump proper is installed in the pump room via seals for the gear coupling and penetrating parts. This isolation is necessary from the viewpoint of hazardous material handling. The cargo oil pump is a kind of volute pump. Liquid, which has been sucked in from the pump's inlet thanks to the impeller rotation, is given pressure and velocity energy and is delivered continuously from the discharge port. Here, you can see the cargo oil pump's main parts. As a large double suction pump, the cargo pump has a mouth ring, mechanical seal, and bearing, one set each on both sides of the impeller. The mouth ring and impeller, peculiar to volute pumps, are installed side by side with a very small gap between them, thereby preventing the high-pressure liquid from flowing backward. The following are typical reported cases of trouble with cargo oil pumps. Damage to bearings. Damage, mainly cracking, to the casing, etc. Damage to mechanical seals. Damage to the gear coupling. And wear of the bottom sleeve. The following precautions must be taken to operate and maintain cargo oil pumps. Conduct steam turbine warming, governor, and shutoff tests. Maintain the optimum pump operational range and strictly adhere to the recommended pipe flow velocity. Never open or close valves abruptly when starting or stopping the pumps. Prevent suction pressures from falling. Prevent bearing temperatures from rising overly high. Check oiling points of gear coupling before lubricating. Check leakage from mechanical seal. And beware of vibrations caused by poor alignment. The pump for LNG cargo handling is a submerged pump that can be found at the bottom of an LNG tank. The motor is made of a special cryogenic metal because it is also submerged in the LNG liquid with the boiling point at -162 degrees Celsius. Here are LNG pump's main parts: the discharge cover, bearing, shaft, winding, rotor, stator. Pump casing, impeller, suction cover, and inducer. LNG liquid is drawn into the impeller via the inducer located at the bottom of the pump. It then passes around the motor, goes through a check valve, and is discharged into the upper part of the pump. Sufficient attention must be paid to the handling of LNG pumps because problems with these pumps can be severe, causing serious damage to the impeller, for example. To operate LNG pumps, sufficient attention and expert skills are indispensable while keeping cargo conditions in mind. Points to consider are: beware of cavitation, the maintenance of proper NPSH. Do not restart the pump while it's idle due to low current. Do not use the pump depending on the state of gas. Do not operate the pump with the discharge valve fully closed. And do not change pump operation abruptly.